Well, hello everybody. Welcome to this first video of 2018. This is Daniel from Basement Tech. Say for the last week or so, I've been able to monitor the temperature, humidity, and explosive gas concentration at the zimKnives shop. And I've been doing this remotely. This video is just a really quick overview of how that's being accomplished. It's really the beginning of a series of videos I want to do about this project, which turned out to be way more interesting than I could have imagined, a little bit more challenging, but I discovered lots of really cool things that I want to share with you. So there are two main parts to this system. This is, I guess I'll call it the base unit, and the remote data collection unit. The base unit's made up of just these components that you see in front of you, literally sort of breadboarded on a piece of wood to do a proof of concept, but honestly I don't see much wrong with just utilizing this for the long run. Over here under this green cover is a 12 and 5 volt power supply. That's a custom designed by Basement Tech 3D printed cover. Printing these covers turns out to be really an easy way to make projects look a little bit better. That terminal strip there just distributes that power, 12 and 5 volts, to the various components that make up this base unit. The outlet on the left there is just a utility outlet and actually serves too as the bottom cover of that green enclosure for the power supply. This next outlet, as it's labeled, is called switched. Inside that box is a solid state relay. I'll show you the components in a minute, but it's going to allow control of anything you plug into it. In this case, I think we're going to plug lights into it so that we can remotely control lights, but also automatically, maybe as the result of a stimulus from the next component I'll tell you about, which is this. It's a just a kind of an alarm system motion detector. This one is a little bit higher end than some of them. It has both the thermal detection and it also has a kind of a microwave backup capability in there. It's not uncommon. It's not, you know, space technology or anything, but I picked that up at a Hamfest, as I indicated in the introduction video that I did a while ago. Under the red cover is a Raspberry Pi. It's a Pi 3, and it's connecting to both the network here and the internet through Wi-Fi. And in between is just called a breakout board that allows easier connection from these Raspberry Pi wires that are fed through that black ribbon cable over to these screw terminals, which make it just a bit easier to connect individual, discrete wires. Also hidden under there are two other things, some transistors, some MOSFET circuits that are going to allow control of as yet unidentified higher current loads, and then a small audio amplifier that drives these two speakers over here. Finally at the top, plugged in and hosted using a program called Motion, is just a webcam to give us remote video, both for sending still photos as the result of a stimulus, like something from that motion control, or maybe a particular value that's coming from the remote sensor, but also, as I say, just to provide video. Those speakers are going to provide noises, if you will, also as a result of stimulus or just whatever we decide is appropriate. So that's the base unit. Let me tell you a little bit about the remote unit now. This is the remote unit. I'm going to take it down from the wall, but just wanted you to be able to see it's just hanging there on the wall collecting data. It's powered through this small wall wart down here, just a lower current power supply, and it's sending the data back via Wi-Fi to the base unit and then on to the internet through a couple other software things that I'll tell you about in a minute. All right, well, here is the remote data collection unit. I'm making up all these lofty titles just because I don't know what to call these things. This is that little power supply that I mentioned a second ago. It's 5 volts at 2 amps, very reasonably priced and probably 2x the power that's needed, but that's a good design margin for this kind of project. This board, which as you can see very clearly is made up of many other Adafruit modules. The purpose of this board itself, this proto board, which is also the blank one provided by Adafruit, is just to make all the connections between those various modules. In the upper left is a 3.3 volt buck boost small power regulator. That's here, very efficient, and provides 3 volts for this, which is really the brains of the operation. It's a ESP-8266 module that I did purchase from Adafruit for a whopping, I think it was $6.95 or something along those lines. But it's very, very capable and also includes Wi-Fi, which is the way we're getting the data back to the unit. A little bit tedious to solder that onto this board, but in the end you can imagine you might use other techniques to get this little tiny module soldered into whatever circuit you're going to use. So working our way down, this I'm going to set this down here. This module right, where's my finger here, is the temperature and humidity module. It's I2C back to the processor. Over here is a explosive gas sensor module, also sold by Adafruit. It has an analog output that's fed into this A to D board down here underneath, the kind of taller board, taller, longer module. That's a bit overkill. It's 12-bit 4 channels. My original intention was to feed that directly into the Raspberry Pi, but I'll talk about that challenge in an upcoming video. Also on this board is a precision voltage reference that you can use to bias out whatever the kind of nominal voltage is coming off of that analog sensor, so that you use all the bits of the A to D most wisely. The buttons are just used to allow setting the CPU module into programming mode, an LED for power, and an LED for successful network connection. A lot packed onto that board, and I'm going to do 2 or 3, maybe 4 videos alone about this hardware and the software to drive it. This was a fascinating learning opportunity to put all these things together, both in terms of just interfacing, which I'm going to do a special video on, and then the logic to tie it all together into something that's just extraordinarily useful, being able to remotely sense my environment and provide that out to an Internet of Things application. Well, you can see what I did with my Christmas holiday. I hope yours was as fun and productive. Look for many, many more details about this project in upcoming videos. As always, if you like this video, press the like button, and if you really like, subscribe. Talk to you soon.